This is Geometry Unit 10, Lesson 1 on quadrilaterals. Now, first of all, we have to know what a quadrilateral is if we're going to be working with them. Quadrilateral, the prefix quad, means four. It's a polygon with four sides. Quadrilateral, four sides. So, we have a theorem that says the sum of the interior angles of a quadrilateral is, well, you may know from previous lessons that it's, or previous years in school that it's 360 degrees. But do we know why? Well, that's why it's true. So let's draw a diagonal in this quadrilateral. So I'm going to draw a diagonal from B to D. Okay, now, what does the diagonal split the quadrilateral into? The diagonal splits it into two triangles. So, if it splits the quad into two triangles, how many degrees are in each triangle? Well, a triangle has 180 degrees, and this one has 180 degrees. So each is 180 degrees. So that means 180 plus 180 is equal to 360 degrees. Any quadrilateral can be split into two triangles, so that means that the sum of the angles will add up to be 360 degrees. So, because you have the two triangles that equal 180. All right, now let's work with a problem that deals with the sum of the angles. In quadrilateral crabs, CR is perpendicular to BC, angle R is x squared degrees, angle A is 7x degrees, and angle B is 2x plus 50 degrees. Find the measure of all four angles of crab. Well, we don't know what this looks like exactly, we just know it's a four-sided figure. And we do know that CR is perpendicular to BC, which means what? Well, that means it makes a right angle. So if we draw CR and BC, let me draw a solid line. Okay, so CR and BC we know are perpendicular. So the C is the common point, so C is going to be the right angle. All right, so I'm going to make this one R and this one B. You can make either one you want. All right, and then it's a quadrilateral, so it has two more sides that we don't know the measures of. I'll make it like this and maybe like that. So there's a four-sided figure. I don't know exactly what it looks like, but it could be this. So C, R, this would be A down here, and B. So just go around in a circle, clockwise or counterclockwise. Now, let's fill in our values. Angle R is x squared. Angle A is 7x. Angle B is 2x plus 50. Okay, so those are my angle measures for the quadrilateral. Okay, so if we want to find the measures of the angles, what do we just know about the sum? We know the sum of the angles in a quadrilateral is equal to 360 degrees. So we add them all up. Okay, so what is the measure of angle C? Don't forget, is 90 degrees. So we have 90 plus x squared plus 7x plus 2x plus 50. 1, 2, 3, 4 angles equals 360 degrees. Okay, so I'm going to combine my terms and put it in order. So this is going to be x squared plus 9x plus 140 equals 360. All right, so this is a quadratic equation. Has to be equal to 0. So we have to subtract the 360. So that gives me x squared plus 9x minus 220 is equal to 0. Factor, factor, factor. X and x. The factors of 220. All right, well, we know it's going to be plus and minus. What multiplies to 220 and adds to 9 would be 11 times 20. So that would be plus 20 and minus 11. So x plus 20 is equal to 0. X minus 11 is equal to 0. So x is going to equal negative 20, and x is going to equal 11. Okay, so now we have to answer our questions. Find the measure of all four angles. All right, we know angle C is equal to 90, so we know that one's 90. Angle R is going to be which one of these? Well, we could use negative 20 here, but would negative 20 work on the other ones? No, so we'd have to reject this one. So x is going to equal 11. So angle R will be 11 squared, which is 121. the measure of angle A would be 7 times 11, which is 77. And the measure of angle B would be 2 times 11 plus 50, which is 22 plus 50, which is 72. Now, if I add all 4 of these angles together, it does equal 360 degrees. So using that, the fact that the sum of the angles is 360 degrees, we can find the measure of all the angles of the quadrilateral. Okay, now, in the quadrilaterals unit, we are going to be working a lot with different figures, whether they're parallelograms, rhombuses, trapezoids, whatever. And we are going to be working in the coordinate plane. So we're going to review the formulas for coordinate geometry. Yes, it's back again. It doesn't come back, and it comes back to haunt you all the time. So let's look at the formulas. First formula that we have is the slope formula. The slope formula, remember, is m equals delta y over delta x. Or you can also write it as y2 minus y1 over x2 minus x1. I just usually use delta y over delta x because it's easier to write. It's faster to write. But it means the same thing as this. So whichever one you use is fine. All right, the distance formula. Distance is equal to the square root of delta x squared plus delta y squared. If you want to write it with delta x like this and delta y like that, you can. Means the same thing. So it would be x2 minus x1 squared plus y2 minus y1 squared. All right, that is the distance formula. All right, the midpoint formula. The midpoint is equal to the average of the coordinates. So it would be x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So these are the formulas that you need to know whenever you do a coordinate geometry proof. You should know these by now, but this is just a refresher because we're going to be using these in this unit a lot. All right, and we also need to review when to use these formulas. So we have 4 basic proofs. You're proving congruent, parallel, perpendicular, or bisect each other. So to prove 2 segments are congruent, what formula would we use? We would use the distance formula. So you would have to find the distance between the segments and then say, yeah, they're equal because they have the same distance. To prove 2 segments parallel, what formula do we need? We need the slope formula. Now, using the slope formula, how do we know that the lines are parallel? They would have the same slope. So to prove segments parallel, use slope formula to prove that the segments have the same slope. All right, so you would have to state the lines are parallel or segments are parallel because they have the same slope. To prove 2 segments perpendicular, what formula do we need? We need the slope formula. And what do we know about the slope of perpendicular lines? They have opposite reciprocal slopes. Opposite reciprocal slopes. Okay, what makes them perpendicular? The slopes are opposite reciprocal. And the last one, to prove that 2 segments bisect each other. Remember, they cut each other in half. If 2 segments bisect each other, what would they have in common? They would have the same midpoint. So we would use the midpoint formula to prove that the segments have the same midpoint. If they have the same midpoint, then they bisect each other. Have the same midpoint, sorry. So if segments have the same midpoint, they bisect each other. When you are doing the coordinate geometry proofs, you have to use the appropriate formula and then explain why you do that. So the parts of a coordinate geometry proof, a graph or a diagram is optional but usually very helpful. If you're not given one, draw one. If you're not given a graph, draw one. Label your calculations. If you're finding the slope of AB, make sure you write slope of AB. If you are writing the distance between x and y, make sure you write distance x and y. If you're finding the midpoint of something, make sure that you label what you're finding. And appropriate conclusions and justifications. You just can't find the distance between things and stop there. Why did you find the distance? Because the distances are equal, that means these two segments are congruent. Or these two lines are parallel because they have the same slope. These two segments are perpendicular because the slopes are opposite reciprocals. Or lines are, these two diagonals bisect each other because they have the same midpoint. You have to have appropriate conclusions and justifications. You can't just do the arithmetic that goes with it and then not explain why you did it. So it's very, very important when you do coordinate geometry proofs to be complete. All right, so that's the beginning of this unit. So you need to know the sum of the angles of a quadrilateral is 360 degrees. And you also need to know your formulas for coordinate geometry.